name's Kel Gray.
And I'm Marla Gray, and we farm here at the Pines in Kiama.
Well, we're 6th generation dairy farm, so we've been here since 1854 milking. But 10 years ago we decided to value add. Originally we were into bottling our own milk and gelato, and we've since added cheese and yogurt to that as well. For the two of us, we've always been interested in trying to create food for people and being gentle on the land, but also doing it in a sustainable way. And that's where we like the idea of renewable energy. A few years ago, we saw an opportunity to work with New South Wales government and be part of a pilot program for the solar energy. And we sort of jumped on that chance.
So my name's Aidan Moore. My role in the DPI on-farm pilot project was I coordinated the consortium of 3 farms through the grant application process, right through the contract signing process, right through to delivery of the solution. So here at the Pines, this system was a 60 kilowatt solar solution, also 60 kilowatt hours of red flow battery solution, integrated into a full farm system. And that keeps power available night and day to keep the produce at the right temperature, and it's a whole system that's been designed to cover the 24-hour period in which the farm is both producing and also storing.
With the energy side, obviously, as soon as you go into value adding, you're adding more equipment and more storage facilities. So our energy consumption sort of rose exponentially, very quickly in a 2 or 3 year period. And since then, that's coincided with energy costs going up.
Because we are located on a hill, lots of storm activity as well. So there were times of the year we were getting, blackouts or surges 2 or 3 times a week, and we blew many motherboards in our large equipment, the pasteurisers, machinery that then we had to race off to replace, and the ongoing sort of stress that caused of having to constantly check if machines were working, or then try and keep the product that we were value adding, so the bottled milk, the yogurt and cheese and gelato, trying to keep that cold when we did not have power. So lots of late nights running generators and just trying to make sure we didn't lose our entire stock.
When we upgraded our cheese facility, we put in solar hot water, and that was sort of an eye-opener about what solar could be and what we could use it for. And so we started investigating solar power. At that stage, we weren't aware of how good the batteries could be and how efficient they were, how much power we could store and then they could give back to us at one time. I think looking at that, at the size of the solar panels and the size of the battery system, it became viable as a not only primary producer but actually processor to be able to move into the renewable space.
So we're here inside the hub at the Pines Dairy Kiama. Over my right shoulder here you'll see that there's the solar inverters. To my left here you'll see is the battery array, and then to my right here we have the brains that pulls all this solution together, that knows where to pull the energy from, where to send the energy and everything in between. So when the system was being designed, the Department of Primary Industries were asking for innovation. The first thing was that we selected Red Flow Australian Tech batteries. The flow batteries were a relatively novel thing a few years ago when the system was designed. The second part of the innovation was to design systems that could transfer energy generated at one metering point at one site and send it to wherever it needed to go, because in the case of the Pines, for example, the business, the overall business, you've got the farm, you've got the farmhouse, and you've got the pantry, which is a retail outlet 2 kilometres away downtown Kiama. So the concept was, rather than implementing 3 different solutions, implement one hub solution and have the ability to send the excess energy to wherever it needed to go. So not only does that provide a cost saving, it also increases and improves the environmental picture of the overall operation. What we're seeing here, Marla and Kel, is that the excess energy generated here at the farm is going down to the pantry, downtown Kiama Township, 2 kilometres away, and we're seeing that half the energy that's powering the shop is actually coming from the farm.
Wow. Yeah, that's awesome. That's great. That's a real savings.
Yeah.
Yeah.
So before we came down here to the solar panel, I had a quick look. On a cloudy morning like this morning, we're producing 40% of our power through these panels that we're using today, and today is a very heavy consumption day because we're in the process of making gelato at the moment. I assumed it worked with sunlight, but it's working with UV, so there's UV around at the moment. So It's our heaviest consumption period for the whole day, and 40% of that is coming from these panels still. If we get a little bit of sun come through the clouds, we'll be at 100% within 5 minutes. Big lesson along the way is when you first start with your feasibility study, you're doing data logging of your own energy consumption, and that came back very interesting results on sort of hot days when we were almost overloading the system, using energy all at once and then nothing at all 2 hours later. Another side was the machinery that we chose to buy, and originally we chose purely on trying to save money at the time, not realising the energy costs that would entail down the track over a 10-year life of that machine. Another side that we've decided to look at since the solar's going in is actually looking at our lifestyle, work ratio and our production sort of schedule so that it works with the sun a bit more. That way we're taking advantage of the infrastructure we've just paid for.
So moving that schedule around and finding those kind of areas we were hitting production when the sun was up, so making full use of it. Then kind of looking ahead to weather events and being able to say, instead of putting energy back into the grid, let's store it, let's hold that in the batteries, and then if we do lose power or we have a weather event, we're going to be okay. So I guess it became a matter of a bit of long-term forecasting, but just making those small adjustments by looking at the data we were receiving and kind of adapting as we went through that process.
So solar panels alone are a wonderful thing, but it's an intermittent generation source. Without the red flow batteries, I don't think you have the full complete solution. You need the red flow batteries to shift the solar power from middle of the day to the nighttime hours. You also need the batteries to provide power when there's the blackout, and that provides the hybrid solution. And for any farm that's interested in undertaking this, my personal view is that they need to spend some time at the front end planning this out, looking at all the metrics and making sure it stacks up. What we do is we work with businesses and take them through from concept to creation. We spend a lot of time in the requirements / specification side of the project. We then work very closely with grade A integrators and designers. And at that point, you've spent a bit of money, but up front you know what the project can deliver and you'll get some metrics around what it will cost.
Yeah, I must admit I was a little dubious at first about the investment, but then when we went through the feasibility process and actually worked out what we'd be investing and what we'd be saving long term, and the added benefit of having a continual supply of power through our processing and farming, it kind of very quickly became something that I couldn't imagine not doing. And for us, I think that's important that we do have partnership opportunities as well. You know, we are a small farm, we maybe don't have the capital investment opportunities that larger organisations or farms do, and that's where those partnerships with the likes of the New South Wales State Government is really important for us, because we do want to showcase what is possible, and then part of that is having people up here and continuing that education. You know, if people want to see the systems working, they want to ask questions, and we're happy to give that kind of feedback and advise and show what we've learned as well. I think it's important that we continue those conversations. We've always tried to kind of find systems that work long term, and that's part of the fun is looking forward to kind of seeing how we can make those improvements over time. It's an ongoing process.